All right, so we are doing explicit formulas. This may sound familiar because we've done it before, and this is Target 9A Day 1. We're going to start off nice and easy. Learning goals. You can write an explicit formula given a list of terms, write an explicit formula given a table, and identify the explicit formula of a geometric sequence when given an initial value and common ratio. So this is kind of what's different. Geometric means multiplying. Okay? And you could also think of it as multiplying and dividing, depending on which is easier for you. And then common ratio is what are you multiplying by, or dividing, if you want to think that way. But most often than not, it's going to be multiplying. Depends on if the numbers are getting bigger or smaller. All right. So let's look at the explicit rule review. Given a formula, you can find the value of any term by plugging in for n. One answer does not depend on the answer before it, unlike with recursive formulas or recursive rules. So with geometric sequences, which is what we're doing, you're going to have a sub n, which is, again, the term you're solving for. So it's the value of the term you're solving for, not the term number, equals a sub 1. So, again, the value of the first term times r, which is the common ratio. So that's what you're multiplying or dividing by. And then to the n minus 1, where n is the number in the sequence you're solving for. So let's take a look at the first example. We want to write an explicit formula given these four terms. So we've got 330, 300, 3000. So all we have to do is write a formula. So this, not changing. Okay, this is not changing. So all we need to do is plug in for this and this. This is nice and easy. What's the first term of this sequence? It's 3. What's the common ratio? What are we multiplying by each time? Well, if we look, 3 times 10 is 30, times 10 is 300. You get the idea. So our common ratio is 10 because that's what we're multiplying by each time to get the next number. And then we keep the to the n minus 1 up in that exponent spot. The other way you can write this if you want is pretty much the same, except instead of this notation for multiplication, we just put the 10 in parentheses. And then make sure that you put this kind of outside. You could put it inside if you wanted, I guess, but just make sure that we're not putting the whole thing in parentheses, because that's a no-no. Next example. So from this table, we want to write an explicit rule. So we need, again, this isn't going to change. This is staying the same. This is staying the same. So all we need to do is plug in whatever our first term is, which obviously would be this. So the value of our first term. And then what are we multiplying by each time? Well, if we look, we're multiplying by 3 each time to get that next number. So it's just going to be a sub n equals 2 this time, times 3, because that's what we're multiplying by, to the n minus 1. Final example for this video. We want to write an explicit rule that represents a geometric sequence that has an initial value, so that's our a sub 1, of 275, and a common ratio of 0.75. So that's our r. So we know what that is. All we need to do is write the rule. So again, a sub n equals our a sub 1 is 275. So we've got this here. We're going to replace a sub 1 with 275. We're going to replace the r with the 0.75. And that's your answer. That's all you have to do. So the first part, just we're kind of getting our feet wet. It may seem really easy. Trust me, it does get a little bit harder, so you want to make sure you really understand these foundations, this basic stuff, before we move on. So any questions you might have, please ask me when you see me in class. And that is it for this video. You guys have a wonderful day, evening, whatever it is.